Speaker is Billy Turner from Arizona State University, and Billy has been one of the founding fathers of land system science and has been involved for long periods in previous projects and in the Global Land Project. And while we are still working on renewing our concepts, going from land cover to land use to land systems, Billy is already a step ahead and will introduce land system architecture to us. And so, Billy, the floor is up to you with a talk called Land System Science, Land Systems, Sustainability, and Land System Architecture.
Well, first of all, I want to thank the organizers for inviting me. I first came to Berlin 40 years ago. Now, I know that surprises many of you young people in the audience because I only look 45 in age. But I just went through, or I've been spending time right in a part of Berlin that I could not go to, or I had to have special permission to go to when I first came. And to see the changes are quite dramatic. Well, I think you're probably tired of hearing about the history of X, Y, and Z and the way forward, but you're going to hear another little history and a way forward, except we heard intellectual history from the first two speakers. I'm going to put that in a little bit of context of administrative history, meaning why we took the courses that we took, because so many of you are, I think just coming into this into this research arena, and you should know or want to know a little bit about from whence it came. And then I'm going to try to push us in a direction forward that I think is consistent with where Future Earth would like to see much of our research community move forward to. So, am I not pushing this correctly? Oh, the right one? There we go. So essentially, I'm going to very, very brief reminiscence about why we took the course of actions that we took and that to lead us to where we are today, and then a way to some notions about how to move forward in various kinds of research. I'm actually going to be focusing on research of urban land, but the idea can be on any kind of system. All right. First of all, why did the original LUC program exist? It existed initially because the International Geosphere-Biosphere Program, which had a very strong land terrestrial component to it, was stuck. And it was stuck because it wanted to model and project future biophysical changes in the land. And they realized that they couldn't do it without understanding how land use was going to change, and they understood that they did not know how to address the question of land use. And so they reached out to the social science / community that sort of linked back and forth between human and environment relations and said, come in, help us. The focus, however, very much was on how can we put all this together, the use and the cover, to project land changes in the future. This meant that it would be highly an integrative study and an attempt to get the biophysical, environmental sciences linked closer to the social sciences. They then turned to the IHDP and said, would you wish to join us in this? And the IHDP at this time was a very new program, and it was searching for ways to develop integrations with IGBP and other units. And so they too jumped in, and together they created or said, let's create this LUC program. And believe me, it wasn't easy to create because the IGBP and the IHDP administratively operated quite differently, and they had different, if you would, intellectual agendas. The one thing that brought us all together, however, is we wanted to make the integration. Anyway, because of that terribly important IGBP emphasis in the very beginning, that put us onto the question of drivers. It put us on the question of monitoring and observing changes and in attempting to produce better models that gave us spatially explicit outcomes of where land might change and what were the biophysical implications of that change. At least that was the original focus. The idea was that somehow this would merge the environmental science community with the social science community that was interested in environment. I would suggest to you that it probably wasn't as successful as it thought, but what it did generate was a bunch of people that I call tweeners. Now, you may not like that term. It means in between, right? Tweeners. Anyway, there were people who already were engaged in human environment studies. All right, so these were, the intellectual academic research force that already said we're interested in the connection. They were the ones that came forward. It wasn't so much that the hardcore environmental scientists or the hardcore social scientists joined in the community. It was these tweeners that really generated that initial emphasis in the luck community. In fact, one of the key things that used to make some of the environmental scientists quite angry is they kept saying, why can't we get the major social scientists? In other words, they wanted the Nobel laureates, if there are any, in the social sciences, right, to step forward, and it was sort of hard to do. Then we reorganized, or the community reorganized, and the attempt was to get rid of the terrestrial ecological component in the IGBP and to get rid of the luck component and to merge those. And so the Global Land Project was the new project that came forward out of this get rid of the other two programs and really make that merger between the environmental and the social sciences and the observational sciences. And it would have a very strong SES, CHESS, the social ecological or social environmental system approach. This was a bit more successful, but not quite perhaps as some of the environmental side wanted it to be, and that was because Diversitas arose at this time. And Diversitas then offered this springboard for the ecological, much of the ecological sciences, and they took that step, although Diversitas then proceeded to set up a whole bunch of research activities that were very parallel to the GLP program, and therefore we had a lot of links and communications between the two. What's very important was what was meant by the word system as this new land project developed. Well, it had three meanings. Okay, the first was linking different ways of understanding. And I would suggest that within much of the social science community, this was missed. It was missed because the signal was we're open to alternative ways of knowing. We're open to qualitative assessments. We're open to how do these fit in and help us produce better models of land change. I don't think that was quite recognized by parts of the community, but anyway, it did move forward. The second form of systems was integrating human-environment relationships through the land dynamics. Okay? In other words, we're not just looking at the drivers of change, but we're looking at the feedbacks and the consequence, and I would argue that even today, that is one of the underdeveloped parts of this integrated research activity. That is looking at what the consequences are of the changes in the biophysical dimensions of land change. And then the last part of systems was linking spatial and temporal scales of assessment. And here again, I think we've underdeveloped this, and I'll come back and talk about it in just a moment, meaning that, there's this old spatial science geographic axiom, you change the scale of analysis, you change the answer. And yet we haven't really delved into that. And we haven't delved into the notion of how we address the same kinds of dynamics at different scales and how that affects the answers that we're generating in our various studies. So what were the advances that happened through this 15, 20-year period? We had, of course, major advances in observation and monitoring, and will continue to have those observations. We have major improvements in modeling, especially with spatially explicit outcomes. By the way, this is a brand new report from the National Academy of Sciences in the United States, which include, by the way, a lot of Europeans were on, well, at least one European was on the committee. But that's not the point. Point is, it's trying to, it was Peter, by the way. So if you don't like it, it's Peter's fault. So, but the bottom line here is it was really going through what have we really learned in our ability to model land change, and where do we need to go? And I would suggest to you that one of the interesting facets of the models that we have today, and I'm really good at pointing out problems in other people's research communities because I'm not a spatial modeler, is that while we have spatially explicit outcomes, many of our models do not have spatial interactions. And so that we're not accounting for as much as I think we should that part of the assessment. And I think this really opens the door for the land people to link more strongly with the spatial sciences community that's out there and hasn't joined us perhaps as well as we should. We've made, of course, enormous advances in going beyond the simplifications of the causes and consequences. Again, this appreciation that you can't do everything through simple hypodeductive methods, that you can't do everything through systematic surveys. And I think we all learned in our modeling exercises that we could improve our models through understanding what we were missing that we often were able to derive from qualitative assessments. And we've made, of course, huge advances in understanding how land changes affect biogeochemical consequences. That, however, has not been so much, I would argue, the global land project community per se, but its linkages to the environmental sciences. And we have ad nauseum, if you would, all these different special features and whatnot, demonstrating the consequences of land change on ecosystem services, which I like to call environmental services, but that's neither here nor there. Where are some of the other advances? We've had a large number of practitioners, and you can see that in how many people wish to come to this to this meeting. And we've had this explosion of outlets that are geared primarily for the land community. And I would argue that within the proceedings of the National Academy of Sciences, there are more papers submitted on land change themes than on any that have to do with sustainability at large, the PNS having a sustainability section to it. All right, and so increasingly, the GLP, I think, is becoming highly aligned with the notion of sustainability and how land fits into sustainability at large. Where do we have a lot more work to do? Well, while we heard today that one of the research from both of the previous two speakers is about aligning the socio and the economic and the political together in addressing the consequences of land change, I think we really have begun to address that, but it hasn't been as well addressed over the whole past 15 years as drivers per se. We've had really sparse conceptual and theory development. And I like to compare ourselves to resilience. There is a resilient science community. I was asked to do a comparison of the two, and I was looking for what were the general conceptual themes that were coming. And resilience has a whole set of, now you may not like them. You may disagree with them. You may think that they're wrong. I think a lot of them are wrong. But that's not what's important here. What's important is that they're developing them. And they're out there attempting to test them. And then I go back to the land community and I say, where are they? Where are they? And I don't see them. There's a few, but they're not as consistent and they're not as, let's say, rigorously stated and addressed as the resilience community has addressed them. Why is that? Well, I give you some suggestions. I think we're a very diverse community, some interested in observation, some interested in modeling, some interested in understanding the drivers. And so we come from such diverse backgrounds that we don't have this consistent set of let's say, topical themes that we're attempting to answer that will let us to get at the conceptual themes behind them. But I also think it's because so much of our studies are one-off case studies. And we really don't have as many examples. That's Eleanor Ostrom up there. She just died recently. But Eleanor, a political scientist who wanted to understand what were the institutional forms that drove commons and made common land successful. sets up a systematic study around X number of cases in ongoing data collection, systematic data collections that can be compared, analyzed, and treated quantitatively. We have very few of those examples. And when I was a member of LUC and a member of the GLP, we used to hit our heads of why we could not get the funding community to step forward and support us in that particular way. But we haven't been good in looking for, pushing for the conceptualizations and generalizations that I think we should in land change. Well, that's where we've been. Here's one way we need to go forward. We know land drives biophysical change. We know it has socioeconomic consequences. If land change science can address the drivers, and it's critical for everything from climate change to biodiversity to biogeochemistry, etc., then land also can be used to mitigate and adapt to climate change, changes in biodiversity, and whatnot. And yet, very few people talk about this, the use of mitigation and adaptation. Okay, so everyone recognizes this. We've had sparse attention to it. Even if you look at geoengineering literature, it never considers land. I mean, land and the changes that people have made in land through the years is the largest geoengineering project ever. Right? And yet, when we talk about geoengineering for climate change, the manipulation of the land is never discussed as part of that geoengineering. Looking at land this way, using land to mitigate and adapt to climate change, is precisely on target, I would argue, with the way future Earth will be pushing much of the community. It is interesting, however, that using land to mitigate and adapt kinds of biological changes is already underway among local planners, and particularly urban planners. And I want to give you an example, and I'm going to focus on the urban heat island. I think everyone in the room knows the urban heat island. And the reason why of megapolitans, large megapolitan regions, but also by climate change. And so they have begun to explore how do you redesign the land systems of cities, right, to confront the urban heat island and climate change. This despite the fact that in 1995, Foreman anticipated all this and wrote a book on land mosaics, essentially about this linkage between how you design land, particularly in urban context. But very few, or I would argue hardly anyone, paid attention to it. This is dead on target to what much of the global land community should be thinking about. So what do we know about the design of land? I like to call it land system architecture, and again I'm going to focus on urban areas in terms of how it affects urban heat island. Well, and I'm going to use a few examples from around the world. So if you look at tree and building cover in Beijing, you can read that as well as I can. Green cover ratio and floor cover ratio gives you 94% explained variance in the daily land surface. LST is land surface temperature. Okay. If you add in building density, you can get 99% of the explained variance in land surface temperature. Now, this isn't architecture. This is composition, but you'll see how that fits in just a moment. Here's a recent study from Phoenix. The only thing that you need to understand on those graphics is that you're getting cooler as you go along the x-axis. You have more trees along the x-axis, and the temperature is on the y-axis. And essentially what this is saying is the more tree fraction you have in a particular area of the urban heat island is generated. And here's one even scaling up, just came out in the Proceedings of the National Academy. Look at megalopolitan regions, meaning conglomerations of big cities together, and essentially showing that by changing the color of the roof, all right, in these large areas, you can temperature, right? So that's just an example. It doesn't have to be within a city, but we can scale up in a very significant way. All right, so now the question becomes, how do we use this kind of information, expand on this information from composition to configuration? Well, we're beginning to slowly understand that it is a combination of composition and configuration that is affecting the urban heat island and can be used to mitigate it, such as location of trees, edge density of the land units, and so forth. And this calls much more attention to the design of the whole landscape, including not just the urban area, but of course the surrounding areas that affect the urban heat island of cities. And so we're looking at the landscape. Here we begin to link with a big unit of research that's coming out in landscape ecology by the ecological community on precisely the same thing. And that gives rise then to this notion that a few of us in the room have been dickering with, called land system architecture, and how can we push that forward? Well, what do we mean by that land system architecture? We mean both composition and configuration, and there you get some examples across the bottom of what we mean by configuration. And what evidence do we have now that by adding the configuration we can understand the dynamics of the urban heat island? Well, in Beijing, 10%, well, this is the generalization, 10% increase in green space gives us a 0.86 degrees centigrade decrease in land surface temperature. But then, if you start adding in configuration, you find that you have an increased significance on the impact of that land surface temperature. This is work out of Baltimore. And here we're seeing that configuration added to composition increases the explained variance in land surface temperature. And there you give some examples, edge density of buildings, and so forth. I don't want to read all those out. I'll give you a moment to take a look. In almost every case, how you change that configuration. By the way, for those of you that don't use FragStats, things like edge density or FragStat metrics. I don't like them so much, but there's this. If they're out there, they're easy to use, and they tell you something about configuration. But so anyway, the point is that the different configurations either increase or decrease the composition constant, significantly increased or decreased by the configuration of the land system. Here's some work that we're doing out of Phoenix. And here we're looking at different. Mesic landscape means you don't have many trees and grass. Mesic means you have trees and grass. And industrial should be clear. And essentially what we're going to do is we're going to see if the configuration of residential units in commercial areas has an impact on the urban heat island. And let's don't go through all the numerics. We wouldn't have time for it anyway. But everything that's circled shows you that there's you get a significant impact on the urban heat, on the maximum daily temperature in those particular cases of the Mesic and in the industrial. And the only reason we didn't find it in the xeric in this particular study is because our sample size for the xeric's landscapes were too small. So increase that sample size, we can begin to find the relationships. And here's one hot off the press, and don't let this burn your eyes. I'll explain it quite easily. So essentially, the y-axis is 12 o'clock at night, right, to 12 o'clock at night. So that's your 24-hour period running along the x-axis. The y-axis, 0 is no significance. In anything above 0 is positively significant. Anything below 0 is negatively significant. And what we're looking at here is, on going from left to right, is the edge density of buildings, the edge density of vegetation, and the edge density of the parcel mosaic. So that's the total edge density of all the land covers in a parcel. Same thing at the bottom. It's landscape shape index of building, of vegetation, and of the parcel. And what you see is there's significant, at different times of the day, significant positive and negative impacts by the design of of those individual parcels. And the design meaning, what are the shape, not just how many trees and grass and building structures, but what are their shapes and how they are put in next to one another in terms of their patterning. Again, controlling for the composition of the land, the significance is there. Now, this just isn't in urban areas. Here's work from Elena Bennett, an outstanding ecosystem scientist at the University of McGill. She's had an ongoing study of a rural area in Ontario, and the way you should read this is that's cultural on the left-hand side. That's cultural ecosystem services, provisioning ecosystem services, regulating ecosystem services, and then the two columns in each of those is composition and configuration. And in every case, you can see that configuration is giving her a higher explained variance in terms of those particular services than is the mere composition. Again, pointing out that we have to get beyond just how many trees there are. What is the actual configuration of those trees? And here she does it in a bit more simplistic way. So everything that is red shows you how much explained variance you're getting for those particular services that you see down the left because of configuration versus blue, which is composition. So obviously, composition and configuration together, what we call land system architecture, goes a long ways towards telling us what's happening to ecosystem services in this particular area of Ontario. This reminds us, of course, that all of this has to deal with trade-offs. It's not just a simple matter of urban heat island. We can design Phoenix better in terms of the urban heat island effect, but what does it mean for biodiversity? What does it mean for water use? What does it mean, right? That's where the trade-off part comes in, again of which the Global Land Project has only begun to address. That is this question of trade-offs and changes in the land system. Finally, I think we all recognize that you could get the parcel right on your far left. You could get the neighborhood right on the second to the left. You could get those right in terms of your land system architecture for urban heat island or some trade-off that you were going after. But that could be totally overwhelmed by whatever the land uses are around that smaller scale that you've just addressed. And so we have to begin to understand what are those dynamics from the outer edge of the hinterlands, however far we want to go, into the urban area per se. And of course, you can ratchet this up to any kind of study that you would wish to undertake. And finally, and I am ending, I remember the first time I put in such a model, right? Research effort, I was told, well, we have the model. It's called INVEST. Well, gang, no. I love INVEST, but INVEST has no spatial interactions, and it can't handle at all what I've just gone through. So anyway, I've suggested in terms of modeling, we've only scratched the surface. We tend to only look at one surface at a time when we do these kinds of spatial studies. Spatial interactions are commonly omitted, and scale dynamics are almost invariably omitted. And what's hugely understudied is how the changes in ecosystem services or the environmental consequences feed back on human well-being. So there's my conclusions, because the 1-minute flag is up, and I hope this has resonated in one way or another. Thank you.